The Solar Podcast is brought to you by Continental Energy Solutions. I'm Tim Montague, your host. Today, using drones to scan rooftops for solar. My guest today is Jason Steinberg. He is the CEO of Scanifly. Welcome to the show, Jason.
Great to be here. Thanks for having me.
You're my first drone company on the show. I love technology and I love drones. The combination is just, it opens so many doors. It provides so many potential efficiencies, and of course provides us all with great marketing photos, as we were just discussing in the pre-show. But truly, this is game-changing technology if done well. So I'm looking forward to learning more about Scanifly and your background. So give our listeners some backstory though on yourself, Jason. How did you get into solar?
Well, it's been a great journey in solar. I just want to say thanks for having me, especially. We are the only drone-based solar software, and I'll get into that in a second. I've been in the solar industry for about 10 years, a bit of a hybrid background. I started with doing it when I was at university, and the school had a grant to put a solar array on the Student Union Center. I was at Muhlenberg College in Pennsylvania, and it must have been well over $8 a watt at the time, and remember those days. But from there, I went and studied over in Europe, and there was a lot of momentum regarding the Copenhagen 15 conference, COP15. I mean, so the combination of being both at school and in that time period and seeing the things going on related to climate change and clean energy, I was really passionate about the space. I spent a couple summers working for rooftop installers in the Northeast, did a handful of installs, a couple of surveys, worked on some sales opportunities, and really got to see what it looked like from the contractor perspective. But after school, I wanted to spend a little bit more time on the macroeconomic piece of solar. So worked for Bloomberg New Energy Finance for about 3.5 years. I was a lead data researcher in North America, based in the New York office, but working with counterparts all around the world. And that gave me a fantastic perspective of all of the different projects, companies, and financing trends going on in the US, but also as it related to the larger global clean energy movement happening. It was a fantastic introduction. While I was at Bloomberg, I did want to get a bit more of experience in the transactional side of the industry. So I eventually left and got a job as a banker for Conresnet Capital, which was providing a variety of financing mechanisms, project finance, corporate finance, and M&A services across the US for solar and wind projects. And so, before Scanifly, my background was, on the installation side, on the research side, and on the finance side, which I think is a little bit unusual for our industry, but gave me perspective of the different ways that the ecosystem really fits together. And in 2018, I joined the founder of Scanifly, John Novak, and Dennis Kobazev, to help really grow the platform at Scanifly.
Excellent. Well, now I understand why you are the CEO of Scanifly and I am not. So that's wonderful that you have such a storied background in the industry and such broad experience. And so let's get into it. What is Scanifly, and why should developers and installers take notice?
Sure. So, from our personal experience at Scanifly, and most people in the industry can attest, the current survey process, to put it bluntly, we think is kind of broken. We believe at Scanifly that the solar industry needs better tools to do their job. I like to say that the solar industry is the energy source of the future, as I think we'd all agree if those of you are listening to this podcast. But the solar industry, especially for residential and commercial applications, are still using 19th century tools for the 21st century's energy source. And so if a homeowner calls a contractor and they're going to go survey a roof, typically they're rolling a truck with a ladder and they're going on the roof with a tape measure, and they're getting dimensions manually. They're writing it down on scratch paper, and then they hand that scratch paper off to a designer who then will manually draft it and push it to AutoCAD or SketchUp and manually draft the design there. It works, but it only works so well. We know from speaking with the industry that over half of solar contractors will say that roughly 25% of projects have redesigns. And a redesign could be a delay on install day. A project needs to get a second round of design effort. It could be an extra truck roll. It could be a change order, right? We also know that the average change order cost is $750 on the residential side and much more on the commercial side. So that manual workflow that I've just outlined facilitates a lot of the challenges that go on in solar, and why I think there's a big soft cost problem in the US still. And so for us at Scanifly, we believe that if you, instead of going on the site with your ladder and tape measure, right, in the same amount of time it will take you to even set up that ladder, just fly a drone. And we encourage solar contractors to integrate drones into that workflow, and then ultimately upload those drone pictures to our software to then create a 3D model of the property and streamline that design process. And once you can get a good survey, we know that that will fine tune the rest of the project so that you have exactly what you need, and it's a fully efficient process to get solar built.
Yeah, somebody who has climbed ladders to get to, 30-foot tall commercial rooftops, I can attest that that is not something that you want to do if you can avoid it, certainly. Residential is a different story. It has its own hazards. I only do, and Continental only does commercial solar. But I realized immediately when I got into solar for full time in 2016 that drones were the future of solar. And it's not just airborne drones, but ground-based drones too for various and sundry applications. Boston Dynamics, for example, is in the news a lot with their Spot. It's a small dog-like drone, which is wonderful for documenting progress on a construction site. And it has 4 legs. It can go anywhere. And it can go many places that a human can't go because it can crouch down and get very low to the ground. So, but for the most part with Scanifly, fly is in your name, right? We're talking about aerial drones, but let's talk about that technology, because most drones have optical cameras, not necessarily thermal, or what are we talking about in order for installers or developers to use Scanifly? What is it that they need?
Yeah, and before I jump into that, I just want to go back to the company's founding, because you talked about the different types of robotic solutions out there, and especially given that fly is in the name. When John started the company, he was just leaving NRG, and his vision was how do we design more accurately, but also ideally stay off the roof. And so what gives you that perspective, and he said there's got to be a way to have that correct perspective of looking at the potential location of where solar should go, but also providing that precision. And drones was the obvious choice. Now, in terms of what drone technology to use, to simplify it, I like to think of aerial cameras and drones really into 2 different buckets. There's a technology called photogrammetry and another technology called LiDAR. And the photogrammetry side is really stitching together geotagged images. Many times they're just JPEG imagery, using key points, correct lighting, and the georeferencing in the EXIF data, in the underlying data in the drone imagery. And that means that each drone photo from a certain type of drone will have longitude, latitude, and altitude stamped in it. And so that's really the technology that we're using at Scanifly is photogrammetry. And it allows you to have accuracy within at most just a couple of inches. Now, the LiDAR technology that I'm referencing is the other side of the equation, which gives you survey grade or centimeter level accuracy. In most applications, that's not needed for rooftop solar. There are some where it's beneficial for commercial solar projects, and will give you really granular data. But I still think for most applications, the cost benefit of a LiDAR-based camera isn't as needed versus the photogrammetry process, which is what we're doing. It really just depends on the project, but typically photogrammetry is needed. And I guess the last thing I'll add to it is camera quality. The cameras themselves, they're all pretty high resolution and a lot of megapixels at this point for drone technology. What matters more is taking a good picture with good lighting and the right angle to create a good 3D model. That's for photogrammetry specifically, though. LiDAR, it's a different story.
And what is the accuracy of photogrammetry?
So quantitatively, we say it's roughly 2 to 3 inches across the 3D model. And that's really a matter of not a Scanifly thing, but of a drone-based 3D modeling or a photogrammetry thing. Anecdotally and qualitatively, we say that, and this is directly from our customers, no change orders, no redesigns, right? So what you survey is what you're going to design is what you're going to install. When the install crew goes out on site, there's no question of if that panel is going to fit. it's going to fit because that's the accuracy that you've gotten. And don't mean to be too self-promotional, but on our website, we have something called the Accuracy Pledge. I mean, and it's a bit cheesy, but we believe that the accuracy of one software is the trust between us and our customers, the solar contractors. And so we have a handful of contractors who stand behind those accuracy claims, that it is within that degree of tolerance and that they aren't experiencing change orders or redesigns. And it's really important to us because that's really upholding the quality of our platform.
Yeah, here at Continental, we use Trimble on every project. And Trimbling takes a long time, so it's slow, but it's extremely accurate. And what we find is that even when we inherit, quote unquote, construction drawings or highly engineered drawings, we often have to rely on our own scanning. So scanning is a big deal. If, of course, we want it to be fast and accurate. And right now we have accuracy. We don't have the speed. And so that's going to be a breakthrough for us when we get the accuracy that we want, but can do it in what we were talking about, maybe half an hour for a large rooftop, right? Where you can, like the rooftop behind me, right? That's a 15-acre rooftop. And small errors will add up, and a large commercial rooftop is not flat. It is an accordion. It zigs and zags at a low tilt so that the water is pushed off the surface and then to the gutters in a perfect world. And not that works seamlessly. I've been on plenty of commercial roofs that have lots of ponding going on because they're old and the drainage isn't working well. But don't underestimate the importance of accuracy for commercial rooftop solar. On a smaller project, if you're dealing with 50 kW, okay, that's fine. I don't think it's a big deal. But if you're dealing with hundreds of kW, I think it's a huge deal. And because nobody likes change orders, nobody likes to have to redo the drawings, etc., or worse, right? Because the choice of product, the choice of racking system can become a fatal flaw if it's not the right racking system. So photogrammetry.
I just want to add to that real quick, if you don't mind.
Yeah.
I think it's interesting because when we talk to residential versus commercial contractors, the pain of inaccuracy is different, and it is a huge spectrum. Briefly on the residential side, right? If you're promising 18 panels and you only get 15, that's a pretty big delta. Not to mention the impact it has on your reputation that you didn't deliver what you promised when you sold the system. And if you're doing that across 2 or 3 roof planes, that's also a huge headache for everyone after the survey designer and then the installer figuring out where they're located. On the commercial side, we hear a pretty big distribution of opinions on what accuracy means. A lot of commercial projects, not all, but a good amount that we come across are in more urban or suburban areas, which typically has pretty good satellite or airplane data. And when we've spoken to developers, they've suggested that is good enough. And we kind of scoff at the good enough line because we know that as the industry matures, as property owners, whether it's a homeowner or a business owner, get more sophisticated around solar, good enough won't be good enough anymore. And the promise of hundreds of thousands of panels, but having that be reduced, like those change orders add up, those redesigns add up as you alluded to. And so I think on the other side of it, we see people that need exact precision for a commercial roof. And so I think that we're going to continue to see the pendulum shift towards a demand for quality and accuracy. And that means better tools and more precise tools that can work faster. We were on a roof last week where and we do this every so often as a team, where we get on the roof ourselves, we take out the tape measure, we take out the surveying tools like the old school stuff, and we validate our accuracy. And we were taping 8 air conditioner units and 15 vent pipes. It was a large commercial roof, and we're doing it for hours. And so we know that there's a need for better accuracy, especially as the property owners are going to be demanding that precision and quality of project.
Agreed. And that's one of the things that we pride ourselves on is super high quality construction, and so I just think I think that there's a lot of glossing over that is done by developers in terms of, oh, it's good enough, and it's not good enough. So I just encourage the industry to be careful and to be rigorous and be better. I also want to point to what's going on in autonomous driving, autonomous vehicles. Tesla has put a stake in the ground on using photogrammetry and not LiDAR, and there is a battle being waged. And Elon Musk has pretty much poo-pooed LiDAR as the solution. And as a Tesla owner, I can tell you that, well, nobody's there yet, including Tesla. And I don't have the beta version yet of the autonomous software, but just watching the videos, I can tell you that it's not there. And will it be there someday? I think it's possible. I'm crossing my fingers because that software was very expensive when I bought the car. And so I bought the promise of someday having an autonomous vehicle. And so for now, I'm tolerating that, but they have a long way to go. So Elon Musk might be able to get away with it, the imperfections of autonomy, but you just have to be careful because Tesla obviously hasn't gone mainstream yet, and I don't know how close Scanifly is to going mainstream. Trimble has gone mainstream. Okay, construction companies use Trimble, and we build data centers, and we build high rises, and we build hospitals, and things have to be right when you're a subcontractor delivering a good and your reputation stands on it. Sometimes I think solar contractors are a little fly by night because it's a one-off. Every job is basically a one-off, and that customer, unless they're a big company with many facilities, isn't going to touch you again. And so you can get away with a certain amount of wiggle room. Now, developers who are doing portfolios have to be careful. But again, I just caution us about being loosey-goosey about these things. We have to be very rigorous because the errors will add up and come back to bite us. Now, let's talk a little bit about the state of LiDAR in the scanning industry versus photogrammetry, if we could, and then we'll talk about some examples of where you guys are shining. Obviously there is satellite LiDAR data, and some of the tools out there, like I think Aurora and Google are leveraging those, right? And it is nice to know what is the slope of that roof, where are the best rooftops, especially in residential. Commercial, it's less of a thing. We're more concerned about keep outs, right? Where are the vents, etc., the mechanical equipment that we have to stay away from, and then how close to the edge of that roof can we get? And then you really want to be accurate, right? Because you don't want to have to take off a whole row of modules, on a big roof. That's hundreds, maybe thousands of modules that are then have to be put somewhere else if you get that measurement wrong. So what are your thoughts about LiDAR?
For us, it's about getting an updated map. The LiDAR that's being used, that's paired with satellite imagery based tools, I think informs a remote survey. It informs a preliminary design. And I think, platforms like Aurora and Helioscope and other proposal tools out there are fantastic. They've really lowered the soft costs when it comes to the sales process. But for us at Scanifly, we believe that getting the most updated map possible is really important. We know that roughly 98% of the solar industry will visit the project site before construction. I like to say you're putting a power plant on someone's property. you kind of want to know what's going on there before you roll the install team out there. And so for us, whether it's photogrammetry, whether it's LiDAR, whether it's hand measuring, if that's still what you want to do, getting an updated map, getting on-site data and an on-site shade reading is critical for us. Going back to your comment on accuracy, we believe that's the best way to get the accurate data necessary. There's also some really good implications about building rapport with the property owner, being on site, showing that you're building a relationship, walking them through the technical specs. we actually believe that site surveyors might be the best closers you have on the sales department, not just your salespeople. So for us, we're fully focused on an updated map. I think the LiDAR technology out there that, I think Aurora is best known for, I believe, and others, it informs the process, but it's important to get that updated map. I just want to also go back to your Tesla comment. We don't know anything about Tesla specifically, so I have no comment on your opinion there. But what I will say is that the growth of, or the excitement around self-driving cars and their use of LiDAR, we have heard and we believe will lower the price of LiDAR technology. And whether it's Tesla or others, and again, I don't know anything specific, but I think that's really beneficial for a lot of industries that have some form of surveying component, whether it be solar or construction or other forms of infrastructure or asset management. Having LiDAR get reduced in price will allow scanning to get even more precise. And right now, photogrammetry is more than enough on the accuracy side. But if you can get more accurate than photogrammetry, why not? The cost benefit is not there. We do have some customers who have spoken to us about it, for example, in Washington State, where you have a lot of trees that cause a lot of shading, and they're 150 feet tall, and their production guarantees. LiDAR scanning would actually be really beneficial in those types of environments. But the cost benefit isn't there compared to photogrammetry. And so we'll wait. But, the direction of LiDAR pricing, because of the excitement around autonomous vehicles, is something to keep an eye on. I think that's an interesting trend that will have widespread implications for lowering the cost of surveying, getting better surveys across the industrial landscape, not just solar or AVs.
I mean, the thing about photogrammetry is, like, humans and most other animals use binocular vision, right? We have two eyes or multiple eyes in the case of, like, spiders. And that allows us to create a very accurate 3D picture of the world. But a drone typically has a single camera, doesn't it? So how do you recreate that 3D-ness to the world using a single camera?
Yeah, so it's really about the number of pictures you're taking, the overlap of those pictures, and their angles. So the methodology that Scanifly believes is best for rooftops or for structures, things that have verticality or a z-axis, as we call it, versus a ground mount, is a point of interest flight path, or known as an orbit pattern. It allows you to take a picture from the drone at an angle, and as you do a circle around a property, you're taking pictures it's every couple of seconds, or achieving roughly 80 to 90% overlap from picture to picture. And so you're taking pictures every step of the way, around a property. And if you do a couple of those circles, which is what we recommend, taking those images and putting them into the photogrammetry process allows you to recreate a really fantastic model. And so how that works is those drone photos have longitude, latitude, and altitude within the data. So they know where to place them as they're stitching them together to create that 3D model. And that's how the 3D model is really a 2-scale model of the property. So yes, it is one camera, but because you have a couple hundred images from all different angles, you're able to recreate that scene in a really accurate way.
Okay, so let's talk about the nitty-gritties of how an installer uses Scanifly. I'm putting your landing page on the screen while we talk through this. I'm taking my drone to the site, flying the site, and then bringing that back, uploading it into Scanifly, and then what happens?
Right. So you fly the drone on site, you upload the images to Scanifly's platform, and then from there, you're going to get a 3D model within roughly 2 hours, similar to the picture you just saw there. And if you go to the, I'd recommend going to the customers tab, so people can see some examples of what 3D models look like. And so the 3D model itself will be to scale within, roughly 2 to 3 inches. And you'll be able to create a roof outline. You'll be able to define your keep out zones. You'll be able to, you scroll down a bit, you'll be able to determine a shading analysis, which is an on-site shading analysis comparable with the Pathfinder and the SunEye, actually proven to be within 1% of accuracy of the SunEye, so pretty much on par. And it's the only drone-based shading application that's been approved by a variety of regulators and lenders like the California Energy Commission, NYSERDA, Mass CEC, Austin Energy, and a whole host of others. You'll be able to define your module layout, and you can do that in line with fire setback zones and keep out zones. You can use your custom modules, however you want to define them. And then you can export that to AutoCAD or SketchUp, or for share materials to promote it, to promote the imagery to share with the property owners. And so those are kind of at a high level, a lot of the design features. So at our core, a drone in our platform is a surveying tool, but our software is a design platform. What we like to say is that you're going to bridge your sales to your construction process in our platform. We're really focused on that survey and design stage, removing the manual tools that currently go on, and in adding back in them the drone and other automation-based tools that can streamline the process.
So how does Scanifly play with Helioscope or Aurora, which are the two major go-tos for designers?
Yeah, it's mostly complementary at this point. So a lot of our customers, I'd say almost all of them, actually have a subscription to Aurora, Helioscope, or Solargraph, or Solo, or a variety of the proposal-based tools, and they're great. They're awesome. I mean, they've got the economics calculators. They have quick proposals that allow salespeople to move quickly. They're great softwares. For us, we start after that in most applications. And so what we have learned is that, about half the industry, give or take, is going to do their on-site survey after you close a sale, right? So just taking a step back, right? Typically the process is a sales process, and then on satellite imagery, and then, an on-site survey. The real technical nitty-gritty stuff happens after a sale is closed. For larger commercial projects, the on-site survey can happen before a sale is signed, so as part of the RFP process or AHJ approval. But even still, step one is almost always a satellite imagery-based design, and occasionally with kind of airplane data overlaid on top of that. We start after that. We're step two. We're going to be fine-tuning your survey. We're going to get you the on-site data, and you're going to finish your design and push to your construction docs. So it's very complementary, and almost all of our customers have subscriptions to those softwares as well.
And then, what does Scanifly cost, and how am I deciding to use or not to use? I mean, certainly we do a on roof, or certainly we're flying a drone over the roof at the proposal stage of commercial projects for the most part, and so we could be using Scanifly at the proposal stage. It's a question of time and materials, though, right? And I use Energy Toolbase for proposal generation, and that integrates nicely with Helioscope, and I love that combination. It's very fast and very robust. But so what does Scanifly cost? And for a company like Continental, we're doing, let's say a dozen to a couple of dozen projects a year, and they're sizable projects. A small project for us is 100 kW. A big project is 3 megawatts, and so you have to disrupt an existing workflow using Trimble technology. But what is the cost benefit analysis that developers and EPCs and installers need to consider?
Yeah, so let me unpack that. I think a couple questions there. So the pricing for Scanifly is a subscription style pricing, whereby a developer will choose a number of projects that they want to do for the year, and they'll pay that down with a monthly figure every month. So if you're doing, let's call it 25 commercial properties a year, you're going to pay Scanifly $449 per month for 12 months, and you'll work down that volume of 25 projects. Now, when it comes to specific to commercial sites and the RFP process, we do have a handful of commercial developers that will use us for part of those RFPs, right? They'll start with a Helioscope or an Aurora. Then they'll move to really inform the process. They'll move to the on-site survey. They'll drone map it. Just takes a couple of minutes. They'll produce the 3D model. They'll fine-tune that design in Scanifly software, and the imagery is really fantastic. It shows a 3D scene. You get significantly better accuracy than other tools. And when you're pitching a large-scale property owner, especially if it's a corporate or a community, having a 3D model that can allow you to visualize that real world context is very powerful. For $449 a month, if you close one or two more sales, it well pays for itself, even before the ROI piece of time saved on site, node redesigns, an accurate ordering of equipment, et cetera, et cetera. So I think a lot of our customers who are building large scale projects are saying, well, if I can win just one more big RFP, it pays for itself, let alone all the other stuff, just as a staging and viewership, a viewing environment, right? The other aspects that people are thinking about when they're making this decision goes back to what you were saying earlier, right? You're on that roof for a day getting all of your measurements, instead you're flying a drone for 30 minutes at most. On the small scale solar side, we've seen people go from 3 surveys a day to 10 surveys a day. We have a guy who did 26 surveys in one day recently. And there was a lot of commercial projects he was 3D mapping in that day as well. So when it comes to kind of, is this a product for you or how you should think about where this fits in? What I would say is if you care about precision and accuracy or good presentation data, and you're currently manually doing anything as it relates to your survey, you should consider drone technology, whether it's us or another application, to start automating and speeding up that process and making sure, therefore, you also have that accuracy as part of it.
And just out of curiosity, are there third parties that you can go to get a Scanifly survey done?
Yeah, absolutely. So for us, we don't want whether you have a drone or not to be an inhibitor to using our platform. We do advocate that for most business cases, having a drone pilot in-house will get you a better value prop. You manage the workflow more easily. You don't pay per scan. They're part of your team, et cetera. But there are a lot of applications, let's say a commercial developer like yourselves that might have sites all around the country, where you're not going to want to fly a drone all over the place. So Scanifly also has a third-party pilot network that we can tap into on behalf of clients. And so if you want us to send someone to Idaho or send someone to Virginia or wherever, we'll deploy that pilot. We'll have the photos collected. We'll upload it to your Scanifly account. All you have to do is give us the address and wait a couple of days and you have all the assets you need.
Cool. Well, we're out of time. I'd love to have you back on the show and do a case study or two where you walk through, okay, here's the case study for a survey, or here's the case study for an EPC or whatever. How can our listeners reach you, Jason?
Feel free to email me directly. My email address is jason.steinberg@scanifly.com. Also on our website, there's a contact us page, which our whole team manages. And if you reference the podcast, I'll make sure to reach back to you. And the third way is LinkedIn. I try to be as active as possible on LinkedIn. So, but feel free to reach out directly. I think what's special about our industry is that, especially for those who have been in it for a long time, is that we're a pretty collaborative and thoughtful bunch who really like to network in the space and are passionate about solar. So yeah, feel free to reach out casually and would happily connect.
Well, I can attest to that. You're very responsive on LinkedIn, so thank you for coming on the show. I want to make a couple of quick announcements. We do these interviews twice a week here at the Solar Podcast. Check us out at cesnrg.com/podcast. You can reach me through the website or on Twitter at TG And, we're doing interviews with technology companies like Yada Energy and the rooftop storage product. They now also have a microinverter. We're bringing you very meaningful discussions about net metering with Bernadette Del Chiaro at the California Solar and Storage Association. If you're not fighting a net metering fight in your state, you will be soon. So check that out. And then reducing the soft cost. We have a series going on that topic with Tom Tansey at Sunspec and Mike Casey at TigerCom. So check it out, cesnrg.com/podcast. I also do the Clean Power Hour with my colleague John Weaver, who is a journalist for PV Magazine and a commercial solar installer. So check that out as well, all at that same landing page. I want to thank my guest, Jason Steinberg, the CEO of Scanifly, for coming on the Solar Podcast today. Let's grow solar.